This is IQE7, the calculation question. When making a dish that requires rice, I usually strain it before boiling it. To strain rice, I put uncooked rice, which has a diameter of 3.47 millimeters in a cylindrical strainer that has a diameter of 30 centimeters and a length of 15 centimeters. As you can see, this is the diagram of the strainer. I then pour water in the strainer. The water then leaves through the mesh sieve at the bottom. The rice is packed such that 70% of the volume of the strainer is taken up by the rice. Find the friction factor, the superficial velocity, and Reynolds number. We have here points 1 and 2, which is the water being poured in and the water leaving. Known is the particle diameter, the diameter of the cylinder, the length of the cylinder, and the void fraction. We're finding friction factor, superficial velocity, and Reynolds number. Properties are the density of water and the viscosity of water. We assume steady state, adiabatic, no flow work, incompressible, and constant gravity. These assumptions prove to be useful in our Bernoulli equation. So we do a Bernoulli equation from point 1 to 2. We cancel out both pressures because both sides of the strainer is open to atmosphere. And we cancel out the velocities because since it is steady state and incompressible, and the area is not changing according to continuity, the velocity would be the same. We cancel out Z2 because we set our height for Z2 at the bottom to 0, and point 1 would be the height, 0.15 meters. So we cancel those terms out and we solve for the friction factor, getting 1.4715 meters squared per second squared. Now then, we use ergon equation to find the superficial velocity. Plugging in all our numbers in, we get the constants A, B, and C, which we will plug in to the quadratic equation to get our superficial velocity. So plugging that into the quadratic equation, we get a superficial velocity of 0.0177 meters per second. So then we use the superficial velocity to find the Reynolds number, and we get a Reynolds number after plugging everything in of 87.5. Because for a flow through a porous media, we need a Reynolds number of 10 or less for it to be laminar. This is turbulent. For the conceptual question, it says if I were to steam the rice from the bottom of the strainer, what would happen to the rice physically as I increase the velocity of the steam? Explain how this would affect the pressure drop. Well, as I increase the velocity of the steam, the rice grains will float and the rice will be fluidized. Because the velocity is increasing, the pressure drop would increase, and we know this from Bernoulli's. But now that the rice is fluidized, the pressure drop would increase at a lower rate because when the rice was packed, the water had to overcome a solid barrier. But now that the rice is fluidized and behaves as a liquid, now the water has to overcome a liquid barrier, which is easier. This will cause the pressure drop to increase at a lower rate since it's easier to pass through liquid than solid.